Hello students, once again welcome to the class. So in the previous class we solved some problem on areas of complex figures, which is made up of plain figures like circle, uh, square, triangle, rectangle, okay, or sector of a circle or segment of a circle. So now we will proceed further and we will discuss some solid figures like cuboid and cube and right circular cylinder as well as right circular cone. So the first I am going to take is the cuboid and cube. So the today's topic is surface area and volume of cuboid and cube. So I am trying to draw a pictorial diagram of a cuboid. Cuboid is nothing but just the stack of rectangular sheets. Okay, I will show you. Let me just draw the. So this is a structure of cuboid. Actually, it is a three-dimensional body. Okay, so you imagine that this is a cuboid where this is length, this is breadth, this is breadth, this is length, this is height. So this will be height, this will be b, okay, this will be b, this will be l, and yes, this will be h. Okay, so now we are seeing only three faces. Three faces are in the back side of it. Okay, so this is a cuboid. So as a demonstration, let us say this is a rectangular sheet. Okay, so if we stack many sheets on top of the other, then we can get a structure like this. So actually this is the cuboid. So this structure has six faces. The first one is this back side, right side, left side, and one bottom and one top. Okay, so there are total six faces. So now we have to study the formula for the cuboid, surface area of cuboid, its volume, and what will be the length of its diagonal. Okay, so let us first understand the surface area. So since this is covering six faces, six surfaces, surface area means the measurement of only the outer part of the outer part of this, outer part of this, outer part of this, outer part of this and this. We are not measuring the dimension inside. Whatever volume it is going to cover, whatever space it is going to cover. So surface area provides only measurement of the outer surfaces. Okay, not inside surface. Okay, so now if you assume this is L, this is V, and this is H, so area of this surface will be L into H. Area of, and same will be here also, back side. Area of this will be B into H. Okay, similarly same will be here, and area of top and bottom will be L into B. So this will be L into B and this will be L into B. So every face is twice, and those are equal in areas. So we can write 2LB, 2VH and 2HL. Okay, 2HL, 2VH and 2LV. So the formula for surface area will be surface area of a cuboid. That will be, let us consider first top and bottom. So this is L into V because this is a kind of rectangle. So L into V, and similar is top also L into V. So that is twice L into V plus, now see this side face. So this is B into H because this is a rectangle. Actually it is not looking like a rectangle, but it is just a rectangle. In order to understand, I have drawn in this way. Okay, so that will be 2 into V into H plus, now let's consider this and this. So this will be 2 times of H into L. H into L. Actually this is looking just like a rectangle. So now we see 2 is common in every term, so we can write 2 into LB plus BH plus HL. So this is the formula for the surface area of a cuboid. Okay, now anybody can ask what will be the surface area of a wall, or the 4 walls, or the 2 walls, or a 3 walls of a room. So the room will be just like this. Either it may be square or square in shape, that will be cube, or in this shape cuboid. So this one, and the opposite faces, this and this one, and this bottom one will be left out. So we have only 4 walls, and we are not considering bottom and floor because one is asking about the area of the 4 walls. Okay, so the ground, that is the floor, and the roof of the room will be left out. Okay, so that will be surface area of 4 walls. That will be 2 times of, this is left out, so that will be B into H, V into H plus, this is V into H and this is V into H, so 2 times. Okay, and 2 times H into L, this one and this one, the outer back side face. So 2 into H into L. So now we can take 2 outside, so B plus L into H is also, so this will be 2 times of, write it in order, L plus B into H. So twice of length plus breadth into height. So this will be the formula for the surface area of 4 walls. Now one may ask you, what could be the longest, what could be the length of the rod that can be placed inside, the maximum length of the rod that can be placed inside a cuboid or inside a room. So that will be just diagonal of the cuboid. So if you place one end at the top corner and the other end at the bottom corner on the opposite, okay, bottom corner and its opposite corner at the top. Place the rod in such a way, and this will be the length of the maximum rod that can be placed inside a cuboid or a room. Okay, so how to find this? So let us draw this. Actually this is not looking, but just it will be a right angle. This will be right angle triangle. Okay, how? You just remember where you are sitting now. You just remember about the floor. So it has dimension length into breadth. Okay, and now you see that this is a rectangular shape, so its one angle will be 90-degree quarter side, and if you join the diagonal, so it will form a right angle triangle, and therefore that diagonal will be this length. Okay, so this will be, let's say this is A, this is B, this is A dash, this is B dash, this is C, and this is C dash. So this also will be 90-degree. So in triangle ABC, according to figure, and no, this is not 90-degree, this will be 90-degree. This actually this is just like this. In order to show on the board, I have made like this. Actually this is like this. Okay, so this is 90-degree, and therefore this will be the perpendicular, hypotenuse. So this is called the west diagonal, and that will be BC square equal to AC square, AB square plus AC square. So AB square is L square, AC is B, so B square. So we found BC square equal to L square plus V square. Now in triangle BCC dash, angle BCC dash equal to 90-degree, and therefore this is a right angle triangle. So therefore BC dash square equal to BC square plus CC dash square. So now BC square is here, L square plus B square plus CC dash square is H. CC dash is H, so square will be H square. So this is BC dash square, and therefore BC dash will be under root L square plus B square plus H square. Okay, so I hope you understood this concept, the diagonal of a cuboid. So this is the formula for a diagonal of the cuboid. So I am writing here diagonal of a cuboid. This is under root L square plus B square plus H square. Okay, so now one thing is left, that is volume. So now I have already mentioned you that surface area covered only measurement of the outer part. Okay, it does not cover how much area inside is covered by this cuboid. Inside, actually this is only area of the outer faces, surface area. So now something we have to study is volume. So let us assume this as a rectangular sheet of unit thickness. So its thickness is 1 unit. Okay, its thickness is unity, that is 1 unit. So if we stack another same rectangular sheet, then its thickness will be 2 unit. Okay, alone it has 1 unit thickness, and what will be its area? L into B. So that will be area of one rectangular sheet with thickness unity. Unity means its thickness is 1 unit. Or you can, instead of saying sheet, you can just say this is a layer. Okay, so that will be area, that will be L into B. Okay, so if we add another layer, then area of this is LB and this is LB. So the total area will be LB plus LB, that is 2LB. So you just write down area of first layer and second layer, that will be LB plus LB, that is twice LB. Similarly, if we stack another layer on it, then area of the three layers, that will be similarly in this way, LB plus LB plus LB, that is 3LB, 3LB, like this. If we add 4 layers, then that will be 4LB. And similarly, in this way, if we proceed and if we add H layer, okay, H layers, then its area will be H times of LB. Okay, so now we found the measurement of outer surfaces as well as inside whatever space it is covering, and that is the volume of the cuboid. Okay, so these are the two basic differences. Volume covers the measurement of all the spaces. Okay, and surface area covers only the measurement of outer surfaces. So this is the basic difference in area and the volume. So now this is the volume. So here we can write this formula. I hope you have write down this, and therefore volume of cuboid, this is LB, H into LB or LBH. So in the book you will find that LBH means L into V into H, means the multiplication of all the 3 dimensions provide us the volume of the cuboid. Okay, so this is all about the cuboid. Now we understood this concept, and using the same concept we can derive the formula for the cube. So cube is nothing, it is just the stacking of square. So in the square, you know that every side is equal, and if we say that this side is A, so the height will be A, the length will be A, and the breadth will be A. Okay, so already we know this. So if we use this formula, then we can derive the formula for the cube. In case of cube, L equal to V equal to H equal to A. Let's say this is A. Since these three dimensions are equal, so let us say that is A. Why we should write 3 times A. Okay. So in this case, surface area will be surface area of cube. That will be twice A into A plus A into A plus A into A, because all are equal. So A square plus A square plus A square, that is 2 into 3A square. This will be 6A square. So the area, surface area of the square will be 6A square. And we know that there are 6 faces in a cube, and one area of one face is A square. So it is easy to say that 6A square will be the area of the complete surfaces in a cube. What will be its volume? Volume of cube. This will be A into A into A, since volume of cuboid is LVH. Okay, so this will be A into A, that is A cube. Means the cube of the side of the cube. And diagonal of a, this will be under root A square plus A square plus A square. Are you getting why I am writing only A square plus A square plus A square? Yes, since L, B and H, all three dimensions, all three quantities are equal, and we have assumed that this is A, so we are writing A. So this will be 3A square. So square root of A square will be A, and we can write like this, under root 3A. So the diagonal of a cube will be under root 3A. So you have to remember this. Okay, this and this one. Volume of cube, this will be A cube. Okay, and diagonal of cube will be under root 3A. So you have to remember these 6 formulas. Okay, so now this is all about cube and cuboid, when it related to its formulae for computing its dimension. Okay, so in the next class we will discuss few problems based on this, or we can go with the formula proof. Okay, so we will handle right circular cylinder and right circular cone. Okay, so let us stop today here. Thank you for watching. If you are enjoying the class, please share with your friends so that they may also get benefit from this channel. Thank you once again.